Hello dear students, welcome to mathematics class. In the previous class we have discussed the definitions and how to write the complementary function of the auxiliary equation or the given differential equation. Now to find the roots of the auxiliary equation, if the equation is quadratic or cubic we can easily find the roots of the equation. So if it is more than 3, 4, 5 like that, then we are going to use the synthetic division to find the roots of the auxiliary equation. So already you know in the previous classes we have used synthetic division and how it is useful to find the roots of the given algebraic equation. So now let us have the look on synthetic division. So now synthetic division, it is used to find the solution of an algebraic equation. Algebraic equation means any polynomial x, y or any other variable. So here we have one example. Find the solutions of x power 4 plus x cube minus 11x square minus 5x plus 3 equal to 0. So if the equation is quadratic, then by using the formula or by using the factorization we can find the values of x. But here the power of x is 4. In this case we are going to use synthetic division. So first we are going to use the trial and error method to find first root of the equation. So let us substitute the values for x 0, 1, 2, plus 1, minus 1, minus 2 and so on. So for which value the equation will satisfy, that will become the first root. So here by trial and error method, let us put directly x equal to 2. You can verify by putting any other values, either x equal to 0, 1, 2, 3, 4 like that. Here the equation is satisfied for x equal to 2. So therefore this is the first root of the equation. If x equal to 2 is the first root, then x minus 2 is a factor of the equation, right? X equal to 2 is the root and x minus 2 is a factor of the equation. So now using this 2 for the next step. So now let us write all the coefficients of this polynomial from higher to lower. The first coefficient is 1, then again 1, then minus 11, minus 5, 3. Here 1 is the coefficient of x power 4 and x cube, x square, x and constant. Then use the first root for the division. So here keep the first value as it is. If it is 1, then consider 1. Then multiply these two numbers, 2 into 1. So 2 into 1, which is equal to 2, right? Then adding these two. By adding 2 and 1 we will get 3, right? Then again multiply 2 and 3, which is equal to 6. Then sum of these two, minus 11 and 6, will give minus 5. So minus 5 into 2, that is minus 10, right? Minus 10, and here the sum is minus 15. Sorry, here in this equation the constant term is 30, not it is equal to 3, that is equal to 30. Then minus 15 into 2 is equal to what? Minus 30, and the last value is equal to 0. So whenever we are going to use the synthetic division, this last value must come as 0, otherwise we have made any mistake somewhere. So therefore this is the, or these are the coefficients for the next lower order equation. Means here its power of x equal to 4, then whenever we are going to write the next equation by using these coefficients, the power of x will be reduced by 1. So therefore, the next lower order equation will be x cube plus 3x square minus 5x minus 15 is equal to 0, right. So here again, by using the trial and error method, we are going to find the next root. So here let us substitute x equal to minus 3. So for x equal to minus 3 and here x equal to 2. So we have not substituted directly, we have substituted by using the trial and error method. So already you know how to use the trial and error method by putting x equal to from 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4 and all the integers, right. For which integer the equation is satisfying, that will be the root of the equation. So here this equation is satisfied for x equal to minus 3. Then again use the synthetic division. Now write the coefficients 1, 3, minus 5, minus 15 and here minus 3. So now the first value as it is, that is equal to plus 1. Then here 1 into minus 3 which is equal to minus 3, sum of this equal to 0. Then 0 into minus 3 is 0, sum of this is minus 5. Then minus 5 into minus 3 which is equal to plus 15 and this is equal to 0. Then the next lower order equation, here it is cube, then here it becomes square. So here x square plus 0 into x minus 5 is equal to 0. So therefore here 0 into x means that is 0 only. Then x square minus 5 equal to 0, x square equal to 5, it implies x equal to plus or minus root 5. So therefore for this equation, that x power 4 plus x cube minus 11x square minus 5x plus 30 equal to 0 has 4 roots. So therefore x equal to 2 is the first root, x equal to minus 3 is the second root, x equal to root 5 and x equal to minus root 5. So here we have totally 4 roots and it is easy to find the roots of the biquadratic equation, that is x power 4 x cube minus 11 x square minus 5x plus 30 is equal to 0. Let us have one more example on this synthetic division. Now x cube minus 6x square plus 11x minus 6 equal to 0. So it is the cubic equation where x cube minus 6x square plus 11x minus 6 equal to 0, which is cubic. Now again by using the trial and error method. So for x equal to 0, x equal to plus 1, x equal to minus 1, x equal to plus 2, x equal to minus 2 and so on. So in such a way that we need to find the roots by using the trial and error method. So here x equal to 1, x equal to 1 will satisfy the equation. So therefore x equal to 1 is the first root of the equation. Then using the synthetic division, first write all the coefficients 1, minus 6, 11, minus 6 and here first root is 1. Now use the 1 as it is. Then 1 into 1 is equal to 1 and minus 6 plus 1 equal to minus 5. Then minus 5 into 1 is minus 5 which is equal to plus 6. Then 6 into 1 is 6, it is equal to 0. So therefore the cubic equation reduced to the quadratic equation, that is x square minus 5x plus x equal to 0. So by using the factorization, we can easily find the two roots of this equation. So here x square minus 3x minus 2x plus x equal to 0, then x is common, x minus 3 minus 2 x minus 3 is equal to 0. So therefore x minus 3 x minus 2 equal to 0, here x equal to 3 and x equal to 2. So therefore for the given equation x equal to 1, 2, 3. So these three are the roots of the given equation. Now let us discuss examples on the linear differential equations with the constant coefficient. So here synthetic division is the basic thing to find the roots of the auxiliary equation. So that's why I have repeated the synthetic division, which you have already learnt in the previous semesters. Let us discuss the examples on linear differential equations with constant coefficients. So here the example given is d square y by dx square minus 3 into dy by dx minus 4y is equal to 0. So already we have discussed the rule to solve the linear differential equation. So what is the rule here? In step 1 we are going to write the symbolic form of the given differential equation by using the operators. And the second thing is finding the auxiliary equation and the roots of that auxiliary equation. And in the third step we are going to write the complementary function depending on the roots of the auxiliary equation. So here first let us write the symbolic form of the differential equation. So here d square by dx square, that is nothing but capital D square into y minus 3 as it is, then d by dx is capital D y as it is minus 4y is equal to 0. Then we can write that y in common, then we will get d square minus 3d minus 4 into y is equal to 0. Now the first step is completed because we have written the symbolic form of the differential equation. Then the next step is to write the auxiliary equation. So here while writing the auxiliary equation we are using small m instead of capital D, because for our convenience we are writing the auxiliary equation as m square minus 3m minus 4 equal to 0. So here instead of D we are using m, that is also same auxiliary equation. If you write d square minus 3d minus 4 equal to 0, that is also okay, but here m is because while writing the complementary functions we are used that e power m1x, e power m2x like that. So that's why we are using this m square minus 3m minus 4 equal to 0. Since it is quadratic equation, it is easy to solve here, no need to use the synthetic division. So that just by factorization we can use. So here it is m square minus 4m plus m minus 4 equal to 0. So you know how to factorize the quadratic equation, because if you multiply two numbers we should have the constant term, and by addition or subtraction of those two or those same numbers we should get the middle one, means the coefficient of m. So here 4 into 1, that will give 1, and minus 4 plus 1 will give minus 3. Then m into m minus 4 plus 1 is common here, then m minus 4 equal to 0. So therefore it is m minus 4 and m plus 1 equal to 0. Here m equal to 4 and m equal to minus 1. So here m equal to 4 and m equal to minus 1. So these two are real numbers and they are distinct. So now look at the list of the complementary function. So here we have two real and distinct roots. Then the complementary function is c1 e power m1x, c2 e power m2x, where m1 equal to 4 and m2 equal to minus 1. So therefore here and here RHS is 0. Whenever the RHS is 0, its complementary function and complete solution will be same. So here roots are real and distinct. Here the roots are real and distinct. Therefore y is equal to c1 e power m1x plus c2 e power m2x, and this is equal to c1 e power 4x and c2 e power minus x, which is equal to y, which is the given which is the required solution for the given differential equation. So m equal to 4 and m equal to minus 1 are the two real and distinct roots. Depending on the roots, we are going to write the complementary function. Since RHS is 0, the complementary function itself is the complete solution. So therefore it is the complete solution.